So next topic is about dermal pharmacokinetics. This topic is quite old and almost everybody knows about this. Pharmacokinetic study is not the new subject or uh, topic. But here, what has been happening in our company means our facility, we have been asked many times that whether we can develop a model which can be suitable for the dermal pharmacokinetics. So we had to come up with a model of NonRodent where we have to use the dermal pharmacokinetics principle. So what is dermal pharmacokinetics? Dermal pharmacokinetics is nothing but you need to evaluate the active moieties or metabolites concentration level or DMPK values at the stratum corneum level or the skin or adjoining tissues. Instead of going for the systemic circulation, it doesn't make sense because once you administer the drug and checking that drug's concentration at the skin level or vice versa, that means applying topically and going to the blood level or collecting plasma and checking the drug's concentration in the plasma, it doesn't make sense. So one has to apply the drug at the topical level, and then you have to collect the skin sample or different layers and evaluate drugs active moiety or metabolites. So a little bit of anatomy. The skin comprises of three layers, as we all know: epidermis, dermis, and hypodermis. Epidermis is again divided into five. The outermost is stratum corneum, then lucidum, granulosum, spinosum, and germinativum. Its thickness is around like 0.1 to 1.5 mm. And here there's a picture is also given there where you can see that the outermost layer is stratum corneum. Dermis layer is almost of thick about 1.5 to 4 mm. And it comprises of collagen, elastin, and sweat gland, oil gland, and so forth. Hypodermis is the deepest layer of the skin. It is also called subcuticular. Here, what we have to understand that we have to take stratum corneum, and dermal pharmacokinetic assumes that the level of drug in stratum corneum is the actual, what you can say, way of going forward to know the DMPK. Comparison of human and animal skin thickness. You can see that as it is self-explanatory that human skin is like almost similar to pig's ear skin, and we say that because average of 20 hairs per centimeter square are present in porcine ear skin, and whereas in humans it is 14 to 32. So that comparison is being taken in many of the time for designing the animal model. And you can see the description of the species. Micrometer, and pig's ear is 10. Epidermis is 36, where pig has 50. Whole skin's, what you can say, width is 1.5, and for pig is 1.3. So that tells something that you can, what you can say, surrogate the pig skin for the human. Little bit about histopathology. So this is about the layout where epidermis and reticular dermis and hypodermis, everything is being given, and comparison. Yes, there are more hair follicles in the human as compared to the pig skin, but they can be comparable. So what types of compounds are being used in dermal pharmacokinetics? So transdermal sites, the drugs where you have to apply topically and you need to have its action topically. And these drugs need not to be absorbed systemically. That means you are using antiseptic or what you can say sunscreen. That is supposed to be remain at the topical. It should not get absorbed systemically. So these kind of different properties are being used to formulate this kind of formulation, and this tells that why dermal pharmacokinetics are important. So once you go through the transdermal to the target sites or within the just below the skin, the drugs could be anti-cancerous drug, which could be game changer, or the drugs against the psoriasis. These drugs are important because you can't administer systemically because it has its side effect, and everybody knows that. So these drugs are remain to be topical, and similarly, once you administer any drug systemically, the drug need not have to reach to the dermal sites, or even if it reach, you need to administer more to reach to its skin level. So there should be a drug delivery system which targets at the topical or skin level. So that is why dermal pharmacokinetics are very important. As I was previously mentioning, dermal pharmacokinetics method assumes that stratum corneum is the rate limiting barrier to the percutaneous absorption. So if you know that what all concentrations are there at the stratum corneal level, you know that how permeable that drug would be. So the next statement states the same thing. Stratum corneum is directly related to the drugs deficient in the viable dermis. And you can say that stratum corneum drug concentration are more relevant for estimating local dermatological efficacy than the plasma concentration. So here, as I was mentioning previously, that stratum corneum's concentration or drugs concentration at stratum corneum is important rather than administering to the systemic level. FDA, what FDA says about that? The FDA says about that are near about 4 time point we should demonstrate the drug uptake, and 4 time points should be demonstrated the drug clearance. So here, as you can say that example, they have been 0.25, 5, 1, and 3 hour, where post application you will estimate the drug's amount or concentration at stratum corneum for the drug uptake. Similarly, for the clearance, removing the drug, you need to see at 4 hours, 6 hour, 8 hour, and 24 hour post. So what all challenges we have been faced? So first is animal ethics. That means we had an idea that we should administer the drug and collect the skin. So how this skin collection could be? So that means you have to administer at 0.5, 1, 3, 4, like that. So once you apply, you need to cut and take the skin from the animal. It's a very painful experience, and no IEC will approve that for a large animal. So a methodology was devised that means reverse. For example, you apply the drug 24 hours before. That will be the source of your 24-hour skin sample, and 0.5 hour skin sample could be just 0.5 hour before. So that in that way, all the skin collection could be done at once, rather than doing post collection you are collecting the skin. Again, we have been asked that not to just limit our work to stratum corneum or extraction of skin. They have also asked us to do the classical DMPK, that whether after topical application this drug is entering into the systemic circulation. So we have to design in such a way that we need to do dermal pharmacokinetics and classical DMPK in a tandem, that it makes sense. For example, if you apply the drug and you start taking the blood collection, the second application will obscure the previous application's drug concentration level. So in that way, we had to manage the study, and you know that first, before the post hour, first collection will be 24 hours after. So during 24 hour to 16 or 8 hour, there are some time period. At that time, you can do your classical DMPK. So that means you can collect the blood, and the second application will come at 12 hour or 8 hour. And we have been asked also to apply the drug at the specific temperature for efficacy problems, because they think that REB application at specific temperature have different absorption levels. So we have been asked to create the temperature at the skin region without any contact. That means we cannot touch the pig skin, because, or else it will contaminate the source of or the site of the skin block. So we had to use the infrared lamps, and we validated the study. That means at a particular distance from the skin, if you are keeping the infrared lamps, at what distances, what temperature is being you are seeing. So with that, we have validated that if we keep the infrared lamp of this exposure at this centimeter, we will be having temperature at the skin level like that. Again, drug permeability across the different skin blocks. Here, once we apply the drug at different skin blocks, there will be drug permeability. That means the concentration or drug will seep from one side to other side. It's quite normal. So you need to find the exact or typical distance between the skin blocks to skin block, which is very important, or else the 24-hour sample and 12-hour samples drug concentration, the skin levels can spread each other, vice versa. This is a classical, what you can say, drug administration procedure, where you can see that area 1 and 7 has been the total 2 into 2 centimeter square of what you can say 4 centimeter square of 12 we have created, and you can see the area 2 and 8 are 24 hours sample, 3 and 9 are 8 hour, 4 and 10 for 4 hour, 5 and 11 for 2 hour, and 6 and 12 for 1 hour. So you can see the 0 time point, area 1 and 7 is a 0 time point. That means you will do. So here you can see that day 0, the 24 hours application will be at 10 a.m. And you can almost see that a 2-hour sample will be on day 1. So that is how it is being done. So now the process of skin layer separation, it's quite typical, and we need to follow the step by step. So all the steps are self-explanatory. However, I'll just show some light over it. Application on the dorsal region, which is quite important because the animal cannot access the region. And there will be 12 marked region which we saw, that we call a skin block. And skin block will have a 4 centimeter of distance between each other, which we have found out after doing trials in such a way that there will not be drug permeability. So after dosing, you will apply the appropriate, what you can say, solvent like ACN water mixture. And then you will rinse the unabsorbed drug content on the skin. After the skin washing, you will do the tape stripping. And it is very important step. The first 2 stripping comprises of stratum corneum. And then whatever the tape stripping is there, that tape strippings are important because that will go for the drug analysis or active moiety analysis. An additional 20 to 30 times tape strippings will be done, and in order to extract whatever stratum corneum is present. And collector strip will be analyzed later. Now, after the skin was collected from using scalpel or dermatom, and it would be put in aluminum foil, and it will subjected to hot air oven for 15 minutes for 60 to 60 degrees Celsius. After the epidermal layer is separated from the dermis layer, fat will be removed, obviously. It will be transferred and weighed. Separated epidermis test area will be separated using scalpel and dermatom. And around 6 mm diameter of biopsy punch will be used to extract the same. It will be weighed, and it will be transferred to the centrifuge tube and sent for the analysis. And this is the video. This video is quite self-explanatory. You can see that how the marking is being done. We cannot draw completely because it's a ink, so it will interfere with the drug absorption. So we just tend to put 4 marks corresponding to 4 corners, and then excess drug is being washed. You can see the tape stripping. It will be subjected to now to hot air oven after this. This is dermatome separating the skin. Biopsy punch, 6 diameter, and then each punch will go into the separate centrifuge tube for evaluation. That's it.